Hello, my name is Victor Tang, and today I'll be talking about one of the many misconceptions in astronomy. People often believe that the sun is burning because they associate the heat and the sunlight to be something similar to that of a candle burning. However, throughout this video I will be proving this concept wrong. So for today's agenda, the first step is going to be a scientific experiment where I'm going to determine the required elements necessary to have an object burn. The second step is to show the relationship or the lack of between the sun and the necessities needed for an object to burn. For the first experiment, the goal is to determine the requirements needed for an object to burn. As you can already see, I have listed heat, fuel, and oxygen as the necessities. Now I will be demonstrating why these requirements are needed for an object to burn. For this experiment, all you need is one candle, one lighter, and a box. As I mentioned earlier, the three requirements necessary for an object to burn is heat, fuel, and oxygen. In this case, the lighter will be the heat, the candle will be the fuel, specifically the wick, and the oxygen will come from the atmosphere. As you can see, right now the candle has two of the three required elements in order to burn. That is the fuel and the oxygen in the air. Without the third element, the heat, the candle will not be able to ignite. Now as I add the third element, the candle will light and continue to burn. If I were to restrict the flow of the candle and eliminate the oxygen, you will see that the candle will be put out. As you can see, the candle has been blown out. As you can clearly see, all three elements, that being oxygen, heat, and fuel, are required simultaneously for a fire to occur. This image is a fire triangle and is a good representation of how an object would start burning. Now we will be moving on to step 2, where we're going to see if the sun has the required elements to support the burning of its fuels. If we can prove that the sun does not have at least one of these elements, then we can therefore say that the sun does not burn. In order to do so, we will look at each element individually. First, we're going to see if the sun has enough oxygen in order to support the level of burning necessary. To do so, we must understand the chemical composition of the sun. This can be done by examining the spectrum lines that it emits. A brief summary of a spectrum line is each atom has its own number of orbits as well as its own orbit energy. When the sun radiates and releases its own energy, each atom will absorb this energy if it's at a specific level of strength. Following that, it will release this energy at the same amount it absorbed it at. This is where you see the black lines in the spectrum lines. Additionally, each atom has its own spectrum lines, so you will see black lines for different atoms. This picture right here represents the sun's full spectrum lines. As you can see, there are various black spectrum lines, and thus we can evaluate these lines to see what atoms are present in the sun. As I mentioned earlier, each atom has its own spectrum lines. This picture right here shows the spectrum lines of the hydrogen atom, helium atom, mercury atom, as well as the uranium atom. If we take a look at the sun's spectrum line in this picture, we can clearly see that the mercury and the uranium atoms have many more spectrum lines than that of the sun's. Therefore, we can somewhat conceptually say that the sun is composed primarily of hydrogen and helium atoms. Although it may be difficult for us to determine the exact composition on the sun by looking at this map, it is a very good overview of which atoms are predominantly existent on the sun. Scientists have evaluated the composition of the sun for many years, and through spectrum lines and many other various techniques, they have come up with this graph of a more detailed percentage of the chemical composition on the sun. As we can clearly see, oxygen accounts for less than 1% of the total atoms on the sun, as well as the percent of total mass. This is significantly lower than the Earth's, and thus it would not be able to support the burning that we believe exists on the sun. Now, it's time to connect all the dots. As we've solved earlier, in order for an object to burn, it requires three main things: heat, fuel, and oxygen. All these elements must be present simultaneously for any object to burn. However, as we saw, the sun does not have enough oxygen in its chemical composition to support this level of burning. Therefore, the sun does not burn, and the misconception that the sun is continuously burning is false. Thank you for listening to my presentation, and I hope it was very insightful